Hello everyone. Today Karthik Vardarajan, Shubham Kumar and Himanshu Jain will be giving a seminar on green cloud meta scheduling. So the topics which we will be covering are introduction, green MAC, which is green meta scheduler architecture, LRAM, local resource allocation manager, green MACC automation, case study inserting of new politics and new variable, and finally the conclusion. So beginning, what is green MAC? The green computing is a vision addressed in recent years aimed at encouraging the use of information technology with a fair and legitimate concern for the environment. The main issue is the economy of resources, which in this area we have the power as a most important factor. Besides, the concern about energy consumption, emission of CO2, which is carbon dioxide, in the atmosphere is an important area for green ID factor. Moving on, now comes the main part. What is green MACC, which will be the epicenter of this seminar today? Its main aim is to schedule virtual machines to hosts in order to achieve SLA signed with the client, where SLA stands for Service Level Agreement. It enables not only the user scheduling policies with QoS in mind, quality of service in mind, but also the user policies whose main objective is green computing in a private cloud. The MACC uses economy modules for negotiation with the user. As the MACC is designed to intercloud, the negotiation of service value with the clients becomes necessary. There are very well defined terms of negotiation specified in the literature, which we will be seeing later in the presentation. Now coming on, green meta scheduler, which is extension of the MAC that enables the offering of services provided in the cloud using green scheduling policies instead of policies that can provide quality of service transferring to the user. We will be able to get a clear picture of the total energy consumption within big data environments. Lack of energy efficient techniques in the designing of big data stream computing system will also be seen. Moving on, now we will come to green MACC's architecture and data flow. So coming to architecture first, there are basically three layers in the architecture. The first one being authentication and layer control. Second layer is job is to negotiate with the user, which needs to response time, energy consumption and other points used by the scheduling policies. Core layer. There are several modules, each with its assignment to the service to be delivered to the user in accordance with negotiation. Now coming to the diagram, as you can see, the system will take data from the user and then it will pass on to the first layer, which is client-server interface. As you can see here, there are three modules: admission, authentication control and trader. It will process the data and will bring to the second layer, which is meta scheduler kernel, and which consists of 6 components: workload prediction, LRAN, which we will be seeing later, scheduling policies, workload engine, green info, MDSM, trigger service, index service, service info. And after processing that data too, we will come to the final part, which is the data center, wherein all our data will be stored, and a little more processing will be done with the help of hypervisor, local scheduler, and then the final data which is collected will be stored in the infrastructure in different data centers. Now, how do we know how the data is processed? For that, we need to know the data flow, and to explain that, I have the data flow diagram with me. First of all comes the authentication control. It will check whether the data is authenticated or not. Yes, then we move on to the user interface, and then it will send a request to the admission control, wherein it will check whether it is being accepted or not. Once it is accepted, it will go to the trader, and then it will put a proposal to the front end of the meta scheduler kernel. Once the proposal is accepted, it will go to front end of the meta scheduler kernel, and as well as the data will also go to the given output data, as you can see in the diagram. And then moving on, we will come to various modules as you can see below, which is NRA and workload prediction scheduling policies, as I explained it in the earlier slides. So this is basically the data flow diagram of a green MACC. Now moving on, we come to virtual machine creation policies. After choosing the data center, what happens? The process moves on to the second stage for scheduling, the meta scheduler, and then the virtual machine is created. And after it is created, there are two policies out of which the user or system has to choose, which are SD2C, which stands for Slotted Dynamic 2-Week Course, and SD4C, which stands for Slotted Dynamic 4-Week Course. And both of these policies follow three important phases. Now moving on, virtual machine allocation policies. The job of this phase is to manage the migrations of these MVs, when the scheduling policy implemented at this stage has this feature. And again in this case, there are two policies used. Another objective of this choice was to prove that the proposed architecture could blend policies of very distinct features and all the scheduling stages without losing the focus either in green computing or in the quality of services.
Hello guys, I'll be carrying on with the rest of the seminar. Now the next topic that we have is task allocation policies. So the objective of the last stage of scheduling is to choose a way to allocate tasks to the virtual machine which have already been allocated in the previous stage. For this, two already existing scheduling techniques were used. Now the techniques were, first of all will be making a comparison of various other architectures with GreenMac, wherein the various architectures that we have are GreenMac, Mac, CA, GCA, Green Cloud, GCA, two levels architecture, HICAM, and UMA, TGC. Now the various parameters for comparison for these architectures are regarding multiple data centers, users, kilowatts, CO2 emission, quality of service, and automation. Now this table we can see like where the comparison stands, what features these architectures have and what features they don't. Moving on, the next topic that we have is LRAM, which basically stands for Local Resource Allocation Manager. Now the LRAM module is able to analyze the information concerning the kind of workload imposed by the user, and after the automatic analysis choose among the policies implemented in the scheduling policies module, that is the ones that offer a better result according to negotiation. Of course we'll be taking the best result that are offered a user. The role of the LRAM is called automation of the GreenMac, as it allows for decisions regarding the four scheduling stages that we discussed previously to be taken in an automatic way. Now the various values analyzed by LRAM for decision making. Now here we have the time versus power consumption graph for light workload and heavy workload. The four quadrants have been mentioned and the various time versus power consumption points have been plotted in the graph. Based on this time versus power consumption, we have various LRAM rules. Choose the case with the lowest power consumption in quadrant 1. As we saw in the graph, there were four quadrants, so we'll choose the case with the lower power consumption in quadrant 1. The second rule is choose the case with the lowest average response time ART in quadrant 2. The third rule, choose the case with the lowest power consumption in quadrant 3. The fourth rule states that choose the case with smaller value from the average between ART and energy consumption in quadrant 4. To do this, we have designed an algorithm which states that First, while the values exist, we'll search for values. If the value exists in quadrant 1, use the lowest value of consumption as stated in the rules for the LRAM. Else, if the value exists in quadrant 2, use the lowest average response time ART value in accordance to the rules, of course. Next, we have if the value exists in quadrant 3, we'll use the lowest value of consumption. Else, use the lowest value of ART and consumption. The point to be noted here is, in any case, any one of these values will only be chosen as the cases are given as else if or else. If one of these cases is satisfied, end and keep executing the next step in the loop. Now we have this datagram representing LRAM choice influence for average response time, which of course mentions the best and the worst case comparison between average response time, and the datagram is presented as time versus workload. Now, Green MAC automation. This interface enables interaction with two kinds of users. Firstly, the regular users, that is the users who uses the system only to request a service, and secondly, the advanced users, the users that are system administrators. The interface for the system administrator enables him or her to insert scheduling policies in any of the 4 scheduling stages that we saw of the Green MAC. Now, Green MAC system administrator interface. This image basically gives us an idea what the Green MAC system administrator interface looks like. We have various search columns, home. These are the various administrator panels. The new variables, the best result, whether we want small or large, and the new policies. Now, Green MAC automation. This image is basically the data flow diagram for the Green MAC automation, which represents either light, we can choose either light or heavy workload. Then Green MAC cloud simulation, which for the forwards us to scheduler stages, which we have already seen: DC choice, create virtual machine, allocate virtual machine, allocate task, and then finally we get the outputs. Now the next thing that we have is Green MAC class diagram. This is the diagram which represents the various classes, various schedules, and various processes involved in Green MAC scheduling, starting from cloud simulation, then item, and then finally we derive the output.
Hello guys, I am Shubham and I'll be talking about the case study inserting a new policy and a new variable. First of all, to demonstrate how Green MAC was designed to be a flexible architecture, initially one needs to define what policy will be inserted. In this work, the policy based on the emission coefficient of CO2, also known as CEB, was chosen. The CEB has an input the variable emission coefficient CO2, and its unit is kilowatt hour, which is consumed in the data center. This article is used to evaluate a private cloud with 15 data centers around the world, more exactly in 7 countries. Moving on. Here we have a list of countries that participated in the case study. These countries were USA, which is present in North America, Brazil, which is present in Latin America, Germany in Europe, Australia and Oceania, South Africa and Africa, UAE in Middle East, and Japan in Asia. Now, the official document of the United States Department of Energy was stipulated for each data center the amount of CO2 in kilowatt hour which is emitted into the atmosphere by each of the selected countries. Now we come to the LRAM algorithm, which was used to determine the energy consumption and CO2 priority. Now it starts with a while loop with the condition of exist value. Then it searches for values. If exist value is in quadrant 1, then the statement to be executed is use the lowest value of consumption. else if execute exist value in quadrant 2. Now we can go to the second if condition, which says that if the exist value is in quadrant 3, execute use the lowest value of consumption, else use the lowest average between CO2 emission and consumption. With this we close the if and then we close the while. Moving on, we now come to the now this is a graph which shows the L-rank choice influence for CO2 emission. And now here we have the best and the worst case for this scenario. On the x-axis we have the workload, on the y-axis we have the grams of CO2 emission. Now here we have another graph which shows the L-rank choice influence. Now this is for the power consumption. Again we have a best case and a worst case. On the x-axis this time is the workload, and on the y-axis this time is the power consumption in kilowatt second. Now finally we come to the conclusion. Now we can conclude that the aim of this work was to present and evaluate the flexibility of a new architecture of green meta-scheduling providing quality of service. In this section, the conclusions of the proposal and the result of this article are presented. The LRAM is a module of the Green Map, an extension of the MAC architecture for green computing in private clouds. The initial negotiation with the user made by the trader module is a relevant one. Then finally, the workload directly influences the result, and it is also an important factor for choosing the scheduling policy in all the stages. Thank you.